A motorcycle traveling at 60 miles per hour overtakes a car traveling at 30 miles per hour that had a 3-hour head start. How far from the starting point are the two vehicles? The last sentence really means how far from the starting point are the two vehicles when they meet. So I began by drawing a picture. Here is the start, this dashed line. This first arrow represents the car, which is going at 30 miles per hour, and which it starts at time 0. The second arrow, which is longer because it has a larger speed, it represents the cycle, 60 miles per hour, and it starts at t equals 3 hours. So there's a 3-hour difference here. The second thing I did was I made a table with 3 columns. The first column, hours from start. Second column, the car distance from the start, and of course this is in miles here. And the third column, the cycle distance from the start. Again, this is in miles. And then I simply put the distance from the start for each of the car and the cycle as time marches forward. So at time 0, they're both at the start, which means 0 and 0 respectively for the car and the cycle. 1 hour later, the car has moved 30 miles. Cycle has not started yet. 2 hours, the car is at 60. 3 hours is at 90. And again, the first 3 hours, the car only is moving. But then at hour 4, they both are moving. The car gains another 30 miles, but the cycle gains 60. Hour 5, the car is at 150. The cycle is at 120. And finally at hour 6, the car is at 180 and the cycle is at 180. So 6 hours that they meet, and 180 miles is the distance from the start. To do this with algebra, we would write an equation for the distance the car is gone, which I'm letting that be represented by c, is equal to 30 times t. 30 is, so this is 30 is in miles per hour. And of course, time is in hours. And then the equation for the motorcycle is 60 times, not t, but t minus 3, because the motorcycle starts 3 hours after the car. So you have to subtract 3 hours from the t. You're using the same clock for both of these. And the condition for them meeting is that they both travel the same distance from the start. So in other words, I would set 30t equal to 60 times t minus 3. So if you solve that equation, you conclude that t equals 3 hours. And you can take that t equals 3 hours now and plug it into either the equation for c to get 180 miles that they've traveled from the start, or equivalently, you can plug that into the equation for m to conclude also that 180 miles from the start.